Alrighty, 26 was rather lengthy, so if you skipped it, good call. It required a lot of steps, but let's go ahead and take a look at it. So Harvey is driving from Austin to El Paso, and that is a distance of 586 miles. 126 miles from El Paso, he got tired of driving and sped up by 5 miles an hour. So we could say the second speed is the first speed plus 5 miles per hour. In this way, he cut 9.5 minutes from the driving time, and we need to find the average speed for the trip. Okay, so the way we want to tackle this is whenever they give us those, hey, some time was saved calculations, we want to approach them through the speed is distance over time formula and rearrange it for time. So the time is going to be the distance over the speed. Now, we're going to use the fact that 9.5 minutes is the difference between doing it two different ways. If Harvey travels the 125 miles at his original speed, that's going to give him some amount of time. Let's say 3 hours. Then if he does it at another speed, but 5 miles an hour faster, and that ends up saving him the 9.5 minutes, then from here we could use this equation to solve for x. So you throw this into your solver, and you find out that his original speed here is 60.77 miles per hour. And his second speed was the 65.37. Oop, I forgot it up here. Okay. Now, to get the the average speed, that's going to be the total distance, which is the 586 miles, over the total time to travel those distances. So we know that he traveled 125 miles at 65.37 miles per hour, and that's going to be some amount of time. And he's going to he did the remaining amount at 60.37 miles per hour. Anyways, you throw that into as a cruncher, and you get 61.4 miles per hour. All right, let's take a look at 27. A spherical balloon holds 80 liters of helium, and the radius has decreased by 30%. So what we can say is that the second radius is 30% less than the first radius. So 0.3 times R1 minus R1 is 0.7. Now, even though they didn't give us a radius, I think the fastest way to do this problem is through ratios. Because it turns out as long as we can write the radius as a multiple of the other one, we can find out the volume as a multiple of the other one. So we start out with an expression that volume is 4/3 pi r cubed, and we do a ratio between those two versions of the formula for the first and second volume. Now the neat thing is that the 4/3 and the pi are going to cancel, and really what we find out is that the ratio of the volumes is equal to the ratio of their radii cubed. And we're going to substitute in that expression for the second radius into the equation. And so from here, we cube the 0.7, and what we find out is that the R1 cubes cancel, and so the ratio of the volumes is 0.343. So from there, we multiply over volume 1, and then we get that the second volume is going to be 27.4 liters. The question is asking how much leaked out. So we take that away from the original 80 liters, and we find out that 52.6 liters has been lost. So this question, even though it sounds pretty tough or intimidating, can be done really quickly. The idea is, okay, R2 is 0.7 R1, cube that, and so that's going to tell us the ratio of the volume, multiplied by the original volume, and then from there, take away the original volume, and that's how much leaked out. All right, 28 seems intimidating, especially because we haven't seen this term anneal, but it just means that we're going to hold it at a temperature for some amount of time. So they tell us that the furnace heats up at 35, and then it cools down at 11 degrees per minute when the door closed, and 17 degrees per minute when the door is open. And they want us to find out how long does it take for the furnace to go from 25 to 1300 degrees Celsius. And then we're going to hold it for 30 minutes, so we're going to add that time, and then back down to 25. Now they're going to open the door when we get to 500 degrees Celsius, and it's going to cool at a different rate from 500 back down to 25. So what do? Well, we find out the temperature difference from here, and then we divide it by that time. That's going to give us so many minutes. Then we're going to add the 30 minutes to hold the anneal. And then when we begin to cool, we're going to cool it from the 1300 to the 2500 at a rate of 11 degrees Celsius per minute. So we divide that over, and then we add that time to the running total time. Then from 500 to 25 degrees Celsius, we find that temperature difference. And then we divide it by 17 to find out how many minutes that is. And then we get a total of 167. All right, 29. They want us to find the total surface area of a square pyramid, and they only gave us the base and the angle between the vertices on a face. Well, remember that the total surface area is going to be the base area, side squared, times 4 of these triangular areas. Now, to get the area of the triangle, it's going to be base times height, but we need the slant height here. Now, how do we get that slant height? Well, thankfully, we can use a little bit of trigonometry. We know that if we cut this base in half, that 5.5, we can cut that angle in half to 19. And then you doing a little trigonometry, that gives us the slant height here. From there, we do 1/2 base times height, 1.11, times the 16.11, cut that in half, then multiply by 4, and then add that to the base area, and there's our answer. Alrighty, number 30. In this case, the volume of a quarter sphere is given, and they want us to find the total surface area. So the total volume of this would be 4/3 pi r cubed divided by 4. And so we use that to get the radius of our sphere. Now, to get the total surface area of this quarter sphere, it's going to be a quarter of that outside sphere area, so 4 pi r squared divided by 4, plus this semicircle and that semicircle with the same radius of pi r squared. So you add all those areas up and you get your answer.